Hi, my name is Sherry Wang, Senior Program Manager of Azure HPC and AI team. Today, I would like to introduce Azure AI and AI infrastructure. AI has reached a critical juncture. It is experiencing quantum leaps in model complexity. This complexity has resulted in a corresponding requirement for IT infrastructure. The need for an AI-first infrastructure has been established, one that can not only scale up to take advantage of accelerators within a server, but also scale out to embrace many servers distributed across a network. Microsoft Azure is the only public cloud that offers purpose-built AI supercomputers. For example, massively scalable IT infrastructures comprised of NVIDIA InfiniBand interconnected NVIDIA 800 Tensor Core GPUs. Azure machine learning facilitates uptakes of these AI-first infrastructures from the early stage of development through the enterprise-degree production deployments that require full-blown ML ops. Scale-up and out HPC supercomputers are both performance and power efficient. HPC technologies have significantly advanced science and engineering, from innovations in hardware to software. Parallelism and communication have been repeatedly leveraged to advance the technologies that comprise HPC infrastructures. Scale-up HPC takes advantage of shared memory to introduce parallelism via threads. When combined with the vector processing capabilities available from GPUs, these SIMT devices have proven extremely effective at processing arrays of data. In fact, multi-dimensional arrays of data. With the added ability of a high bandwidth, low latency interconnect fabric, scale-out HPC takes advantage of distributed memory for parallel computing by interleaving computational and communication across a network of computer nodes. Scale-up and out HPC combines the attributes of vertical and horizontal system scaling to address the most demanding workloads from science and engineering. Microsoft Azure, in partnership with NVIDIA, delivers purpose-built HPC and AI hardware in the cloud to meet even the most demanding real-world application workloads at scale, while meeting price performance and time-to-solution requirements. And with next-generation machine learning tools included, you can incorporate intelligence with your workloads to drive smarter simulation and empower intelligent decision-making. Scale-up and out infrastructures based upon NVIDIA GPUs and NVIDIA InfiniBand interconnect fabric ranks amongst the most powerful supercomputers on the planet. Azure placed within the top 10 on the top 500 and has 4 more placements with the top 35, a remarkable and notable first for the public cloud. You can find more information from the link above. The progress of AI has been astounding from just a few years ago, with solutions pushing the envelope by augmenting human understanding, preferences, intent, and even spoken languages. AI is improving our access to knowledge, helping us provide more efficient solutions that fuel transformation beyond imagination. With the rapid growth of and transformation, AI's demand for compute power has grown by almost 4 orders of magnitude, outpacing Moore's law. With AI powering a wide array of important applications, including natural language processing, robot-powered process automation, and machine learning and deep learning, AI companies are finding new ways to get more out of each piece of silicon using tools like mixed precision modes, enabling them to do more with less. The only way to satisfy the expanding ambitions and imaginations of the AI research community is through massive scale. And the only way to scale up real-world applications without slowing down performance is via fast, low-latency connections such as InfiniBand interconnected GPUs from NVIDIA. for programmatic exploitation of interconnected GPUs as accelerators with scale-up and out infrastructures to deliver the kind of performance that today's workloads demand. Back to 1956, artificial intelligence was a broad discipline, the value of which has yet to be realized. 14 years later, machine learning is the most highly relevant subset of AI in use today. Nowadays, the most demanding requirements originated from deep learning, a subset of machine learning, a skill for extracting insights from big data sets. These terms are bandied about interchangeably. An AI-first infrastructure and toolchain for any skill aims to address this challenge. AI-first infrastructures and toolchains are proving to be one of the value in most industries. Here we provide use case examples from manufacturing and retail, as well as compelling customer stories from healthcare. AI-first infrastructures and toolchains are having significant impact in manufacturing. Based upon industry trends, we've identified two use case examples, namely predictive maintenance and product quality, by using NVIDIA GPUs on Azure for predictive maintenance and product quality. Customers can see a plethora of benefits in scaling, speed, quality, and accuracy. Of course, these benefits are the outcomes derived from technology-based solutions that address the nuance of each scenario. Each of these examples requires an AI-first infrastructure and toolchain as the scenarios under consideration are demanding ones. For example, to significantly reduce false positives and negatives in predictive maintenance, to account for a subtle nuance in ensuring part quality. The results speak for themselves, results that impact the manufacturer's bottom line.
We are a premium manufacturer. Our new 5th generation electric drivetrains sets standards. Our biggest challenge so far is the transformation from the combustion engines to the new electric drive systems, which require completely different production processes.
We choose especially Azure Machine Learning to be part of our solution because it has a rich functionality and also with the computational power provided by NVIDIA's GPUs. For the trainings of our models, we are using Azure Machine Learning and also NVIDIA VMs.
The no-code approach is the key here. The solutions are designed as a self-service. The complexity lies in the back-end. The user does not need any specific IT knowledge.
After the robot has taken the pictures, they are transferred to Azure for the model training. There we use our RCV labeling tool in the RCV cockpit to create a project, to label the pictures and then also train the model. And for this connection to the model training, we are using Azure Machine Learning and also NVIDIA VMs. The models are deployed on NVIDIA GPUs on the shop floor that provide the computational power that is needed to realize the corresponding response times. The solution supports all this evolution until we get a highly robust and fully automated inspection solution. The RoboSpector solution combines the strengths and abilities of the included partners Microsoft, NVIDIA, Robotron and Wandelbots. The result in the end is a highly robust and automated inspection solution. It adds much benefit to flexibility and agility of the whole production.
Our production system is cutting edge. We drive innovation. We rely on effective applications that can be integrated cost-effectively and flexibly.
AI-first infrastructures and toolchains are having significant impact in retail. Here, we've used deep demand forecasting and the connected store as use case examples. Primary benefits include improvements in performance, training times, TCO, ROI, and shrinkage, all key areas for companies in the retail industry. Like in manufacturing, these benefits are the outcome derived from technology-based solutions that address the nuance of each scenario. Each of these examples requires an AI-first infrastructure and toolchain, as the scenarios under consideration are demanding ones. For example, to significantly improve the timeliness and accuracy, demand forecasting for retailers, to deliver a frictionless experience to customers in a retail storefront scenario. In both manufacturing and retail, use is made of Azure machine learning to build and operationalize deep learning models that execute on NVIDIA GPUs, whereas model training makes its use of the N-series virtual machine on Azure inferencing is often shifted to the edge. These data-driven solutions require sophisticated deep learning models that are much more sophisticated than those offered by machine learning alone. In turn, this sophistication demands an enabling AI-first infrastructure and toolchain. But this infrastructure is not only being used in manufacturing and retail, but also the healthcare industry.
At Sensign Health, we work with some of the largest pharmaceutical companies delivering research insights based on questions that they pose on real-world data. The aspect of COVID for us was a massive amount of uncertainty. The one thing that we did know at the time was that diagnosis at scale would be a major part of what was going to be needed. Magnify is a solution which allows you to turn a phone remotely into a diagnostic tool. We worked out that we could incorporate our image capability using very powerful neural networks to actually very accurately determine what that reading actually was after you've taken it. And the reason that's important is that the human eye and the brain that interprets the image is very varied. Too many false negatives puts an added burden on the healthcare system. It means that more people will be misdiagnosed and therefore take incorrect action. Magnify puts clinical grade diagnostics in the palm of any end user, not just a healthcare professional, but a mum, a dad, an aunt, an uncle, doesn't matter.
We were faced with the unique challenge of supporting around 500 transactions per second. The way we did it is leveraging on Azure's capabilities in GPUs and the machine learning behind it.
Azure has all of the governance certificates that enable us to meet those requirements, from GDPR through to some of the security standards. We examined multiple GPUs that were available to us under the Azure cluster. The one which gave us the most advantage was the Triton inference engine. We were able to go from a 2-second turnaround time from running all these algorithms to a 0.1 second, and also enable us to deliver very, very high accuracy results, several times higher than other GPUs that we tested.
If we hadn't had a similar technology offering from Azure, it would have been really difficult to achieve what we have done.
We'd never have delivered a diagnostic solution via a camera phone using machine learning technology had it not been for COVID and the partnership that we had with NHS and Microsoft and NVIDIA. We did something really meaningful, and that is what makes all the difference in this world.
This is just the start of the conversation for AI and AI infrastructure, and we invite you to read more in our AI-first infrastructure and toolchain for any scale white paper at aka.ms/AIWP. Thank you for joining today's session.